guys, my name is Jean. I work as a data scientist for 4 years. If you are interested, you can see my LinkedIn profile. It's under the video in description. So today I start the series dedicated to ML algorithms, more specifically for using them for sports betting. And today we will talk about clustering. What is the main idea? We have the game to predict, and what we do, we looking for similar games by some features and see how they ended. So based on these results, we conclude, for example, that these games end in 3 or more goals 60% of the time, or we conclude that 50% of the time the home team wins. So let's take a closer look at what we will learn today. Okay, I have an example here, the game between Tottenham and Arsenal, and we select similar games. By saying similar, I mean that Tottenham and Arsenal score a lot, and we have a small table with only 5 games, and all these teams in this table also score a lot. What we do, for each game we count how many goals were scored, more specifically more than 2 or less, and we see that in this table we have 3 games in which 3 or more goals were scored, and only 2 games, Arsenal, West Ham and Liverpool, Tottenham, in which 2 or less goals were scored. So based on these results, we conclude that these kind of games end in 3 or more goals in 60% of the time. So it's clear that this is an exaggerated example, but it shows how model works. So let's take a look at how we build our model. First of all, let's define what this similarity is. On this slide we have 1 player and 4 teams: Astra, Iris, Gladiolus and Tulip, and we define which team he belongs to. So we need to see which of these teams he looks like. What is the criterion of similarity in this situation? The color of t-shirt and his hair. By this criterion he belongs to Gladiolus team. The situation with the games is the same, so we need to find features that tell us that these games are similar. What our parameter would be? Let's do this. Let's count team's performance, for example Chelsea, but we don't count how many goals team scores in each game. We will assume that there can only be 2 outcomes. The first one, if team scores less than 2 goals, we give this game value of 0. Otherwise, the outcome is 1. This will be our parameter. In what percentage of games has team scored 2 or more goals? So, before each round, we calculate this value by a method I showed before. And in this graph we have an example for 4 teams. As we see, Liverpool scored 2 or more goals 80% of the time. For last 10 games, Chelsea 50%, Leeds 40%, and Newcastle 30%. So we have value for each team. That means that if we take the upcoming games, for example, Chelsea versus Newcastle, we can see that the Chelsea scored 2 or more goals 5 times for last 10 games, and Chelsea and Newcastle only 3 times, and that means so we have feature values for our game. It consists of 2 parameters. So home team performance 50% and away team performance 30%. Using this method we can calculate feature values for each game and put this point on the graph for all games of both the season. Actually we can take 2 seasons, 3 seasons, as many as you like. So I mean we take Chelsea Newcastle, we know for Chelsea the value is 50, for Newcastle 30. We find 50 value on y-axis, find 30 on x-axis, put this point on the graph and repeat this operation with all games of the season or the seasons, and we end up with a large data set which we can divide into clusters. So in our example I divided our data set into 4 clusters. I used method for clustering. There are a lot of methods, but I used the method which is called k-means. I don't want to get into math, but anyone interested can Google how it works. But the main idea is that all points of each cluster are gathered more or less evenly around its center, like constellations around a star. And we have 4 clusters. We can take a look and see, for example, that in cluster 0 we have games. Cluster 0 includes games where home team has an average performance about 50 and the away team rarely scores. We can take another cluster 3. It includes games between bottom teams, so both home and visitor do not score anything. When we trying to make a prediction, when we see the upcoming games, we can take it, we can identify which cluster this game belongs to, but we can't make prediction because we don't have the results. So that is, we are building our model. We have feature values, which is home team performance and away team performance for last 10 games, but we don't have target value. So let's calculate it. What will we do to calculate the target value? We take each game from each cluster and count number of goals scored, but as we did before when calculated the team's performance, we don't need the exact number of goals. We will assume that there can only be 2 outcomes for a game if less than 3 goals are scored. We give this game value of 0, otherwise the outcome is 1. So for each cluster we can calculate the average value, and we see, for example, that for a cluster 1 we have average value is equal to 40. That means that only 40% of games ended in 3 goals or more, and that will be our prediction. So average value of each cluster calculated by this method is our prediction. Let's take a look at summary table. Actually, here I have the real data of English Premier League for last 8 seasons. Yeah. So I calculated the average percent over time when 3 or more goals are scored for each cluster. So, and in each row I have specified the coordinates of center, so we can check it. For example, cluster 0, 50% for home team, 25% for away team. Yeah, that's correct. So the game between average home team and bottom away team, and half the time and with 3 goals or more. For cluster 1 it's 55%, cluster 2 between top team and average home team 60%, and interesting thing for cluster 3, which include games between 2 bottom team which rarely score, so 25% both. So we see that 45% of these games end in 3 and with 3 or more goals, which is much more that you would expect. Okay, so for each cluster we have average value, and when the round is coming, new round is coming, we take all upcoming games, we identify which cluster each game belongs to, and we take the average value for this cluster as a prediction. That's our simple model. As I said, we have built a simple model. The question is how to improve our model, how to improve our prediction for real betting. And I have highlighted on 4 points. The first one is that we can increase number of features for clustering. So in our model I use only 2 features, home team performance and away team performance, just because it's easy to plot. But if I had chosen 3 parameters, it would have been more difficult to draw a graph. If I had chosen 4 parameters, it would be impossible to display it. But as you don't need to draw a graph, you need to build a better model, so you can calibrate this feature. The second one is the number of clusters. In our model I divided our data set into 4 clusters, but you can choose 5, 6, 12, 20, as many as you like, and see how many brings you best result. The third one is we can calibrate the number of previous games for calculating the team performance. So in our model I take 10 previous games, but no one is stopping you from taking 11, 12, 20 or even last 2 seasons. Okay, the last point is that each cluster can be divided by decision tree. And the point is that clusters divide our data set more or less evenly based on all parameters, while a decision tree can divide our data set, or in this case cluster, not equally and only by 1 parameter. For example, we can take cluster 2, draw the line here, so that one part contains only games between 2 top teams. So you can see here the home team performance about 70%, the same for away team. And another part contains the remaining games. And see what kind of division brings the best results. Okay, so that's it for the theory. Let's go to practice. We will write script in Python and try to build our model based on real data. Okay, here I have the small script that calculates our data set. So first of all, we import all libraries. Especially I want to pay your attention to this line. We import k-means method, as I mentioned before, for clustering. The second step we have here, I have prepared the data for English Premier League for last 8 years. Yeah, we can see that the game starts from 2014. Okay, this cell calculates the values of our features. We have 4 features here: home defense, home attack, away defense, away attack. As you see in the slide, we use only 2 features. Here we have 4. This line tells us that we divide our data set into 6 clusters, and here we have and this line shows that we take last 10 games. Don't look at number 11, just believe me, it takes last 10 games. Yeah, and here we create our clusterization algorithm. So next step, we feed this algorithm to our data set, and we create a new column which is called label. You will see that our initial table with only results transformed to the table with value of features for each game, total number of goals scored, number of cluster, as I said here, and I created the column which is called over, in which we assign value 1 if more than 2 goals scored. Otherwise we give this game value of 0. So you just can check. Here we have 5 goals and the label is 1. Here we have 2 goals and label is 0, etc, etc. So this is our final table. We have a number of clusters for each game, and we can count the average value for each cluster. That is our prediction, actually. So we can see that, for example, cluster 0, so average number of games in which 3 or more goals scored, 57, almost 58%. Cluster 1, 56. Cluster 4, 47. So what we can do next? We can save this table to Excel. Let's do this. Where is it? Here. Let's download it. Okay, so next step. Next step, first of all, we fix the headlines. Also, I would like to color it. Where is it? Here. Also, I mark this label, also color it. Okay, and let's take a look at the last season. (2022). Okay. I think that's enough. So, and sort this this part by label. And we can see, for example, so cluster 0. Cluster 0 includes games where the home team concede nothing, scores a lot. Away team also concede nothing and also scores a lot. So roughly speaking, this cluster includes games between top teams. So we can see Leicester MU, Tottenham Chelsea, Liverpool Aston Villa, Arsenal City, etc. And so and as we saw before, so these kind of games in 58% of the time and in 3 goals or more. Knowing the probability for each cluster and based on coefficients for each game, we can calculate on whom to bet money, and eventually we can calibrate our model to get the best results, as I showed in my presentation. So generally that's it. Thanks for watching. Goodbye.